Welcome to my channel. In this video, we are going to discuss about the third unit multiple choice question and answer. So already we discussed the three parts for the third unit. Okay, so this is the one of the thing. So in this case, we are going to discuss about the analysis of continuous time system in Laplace transform and Fourier transform. Okay, so the first question you see, the impulse response h of t of the LTI system is given by h of t equal to e power minus 2t u of t. The frequency response h of omega is dash. Okay, so if the impulse response of the system means how to calculate the frequency response h of omega means the frequency response h of omega is nothing but it's a Fourier transform of the impulse response. Okay, so already that is the impulse response, the relation between the impulse response and the Fourier transform is impulse response and frequency response is that the frequency response h of j omega or simply h of omega, it is nothing but it's a Fourier transform of the impulse response h of t. Okay, so for the given h of t, we have to take the Fourier transform. So what is the given h of t? H of t equal to e power minus 2t u of t. So you just take the Fourier transform of e power 2t u of t. So using formula you can solve, or otherwise already you know the standard Fourier transform pair e power minus at u of t. So what is the Fourier transform answer? Fourier transform for e power minus at u of t is 1 by j omega plus a. So here the value of a is 2. So that's why the answer h of j omega is 1 divided by 2 plus j omega, or use the Fourier transform formula in order to solve this one. So we may get the same answer only. So the answer is 1 by 2 plus j omega. So here 1 divided by 1 plus j to omega, sine omega by omega, 1 by 2 plus j omega. Okay, so this is the answer. So the relation between impulse response and frequency response is nothing but the two things Fourier transform pair. Okay, that is the thing. Then next question, find the inverse Laplace transform of 1 divided by s plus 1 the whole square. So we have to take inverse Laplace transform for the given function 1 by s plus 1 the whole square. Okay, so here, so we have to find inverse Laplace transform. So already you know the standard pair, it is nothing but e power minus at. Okay, so e power minus at u of t, the Laplace transform answer is that 1 divided by s plus a. Okay, and the function t. Okay, the function t is having the Laplace transform, that is the ramp function. It is having the Laplace transform is that 1 divided by s squared. So if you are combining these two signal means, so t into the signal t into e power minus at u of t. The signal t into e power minus at u of t. So it gives the Laplace transform answer is that 1 divided by s plus a the whole square. So 1 by s plus a the whole square. So this is the answer for t into e power minus at u of t. So here you see the x of s value 1 by s plus 1. In the place of a, what are the thing is that number 1 is there. So that's why the inverse Laplace transform of this 1 by s plus 1 the whole squared is t into e power minus the a value is 1. So t into e power minus t u of t. So the answer for inverse Laplace transform of this 1 by s plus 1 the whole square is t into e power minus t u of t. So this is the answer. Okay, so in this way, in a standard standard Laplace transform pair, we can solve in a easy method. Okay, then the next question, find the inverse Laplace transform of 1 by s plus 1 the whole squared plus 1. So you see the structure 1 by s plus 1 the whole squared plus 1. So this is in the Laplace transform of, so you know the Laplace transform of e power minus at sine omega naught t. Okay, so already we solved this problem. So these are all the standard Laplace transform pair. You have to remember it. Okay. E power minus at sine omega naught t is having the Laplace transform answer is that omega naught by s plus a the squared plus omega naught squared. So you just compare this equation with the given thing. What is the given thing? 1 by s plus 1 the whole squared plus 1. So in the place of omega naught, you see in the place of omega naught, what is the answer is there? 1 is there. So omega naught value is 1. And in the place of a, that is s plus a the whole square, here s plus 1 the whole square. So in the place of a, what is the 1? A is equal to 1. So that's why this 1 divided by s plus 1 the whole square plus 1. This is the Laplace transform of which signal? E power minus at sine omega naught t when a equal to 1 and omega naught equal to 1. So that's why the answer is e power minus t sine that is omega naught value is 1. So sine t u of t. So this 1 by s plus 1 the whole square plus 1 is the Laplace transform of e power minus t sine t u of t. So the answer you check e power minus t sine t u of t. So this B is the answer. Okay, so there is a question. So in if the value that is instead of this one here there may be a is given means the answer is that that is in the place of 1 that 2 is given means so the answer is that e power minus 2t sine t u of t. Okay, so that is the answer. Then the next one in cascade form realization the transfer function can be the 4 choices given. So you know the 4 types of realization: direct form 1, direct form 2, cascade form and parallel form. Okay, in cascade form realization, so the given transfer function, the higher order transfer function h of s can be splitted as a multiplication of h1 into h2, h3 and so on, where the h1, h2, h3 is said to be the single order transfer functions. Okay. Similarly, in parallel form realization, the given transfer function h of s, we have to split as a addition of the first order transfer function h1 of s plus h2 of s plus h3 of s and so on. Okay, where this c is a constant. So this is the question. So in cascade form realization, the transfer function can be expressed as a product of single order transfer function, can be expressed as an addition of single order transfer function, both a and b, expressed as a convolution of a single order transfer function. So the answer is expressed as a product of single order transfer function. So in cascade form, the h of s can be written as the product of h1, h2, h3, etc. Okay, similarly, the next question, in parallel form realization, the transfer function can be expressed as a addition. So you see h1 plus h2. So using the partial fraction method, we have to split the given h of s as a some constant c plus h1 of s plus h2 of s and so on. Okay, so that's why the transfer function can be expressed as an addition of a single order transfer function. Okay, this is the answer. Then the next question, the impulse response of the continuous time system is given as h of t equal to 1 by rc e power minus t by rc u of t. Determine the frequency response h of j omega. So already you know the relation between small h of t and frequency response. What is the relation h of t and frequency response? If you are taking Fourier transform, okay, Fourier transform for the impulse response, we will get the frequency response. Okay, so you just take the Fourier transform for this given h of t. Okay, so you just see. So you know the Fourier transform formula. So the Fourier transform of impulse response, it can be written as capital H of j omega. So the formula is that integration minus infinity to infinity h of t e power minus j omega t dt. So next step, we have to substitute the value of h of t. So what is the h of t? The h of t is 1 by rc, where r is the resistance, c is the capacitor. So 1 by rc is a constant. So 1 by rc e power minus t by rc into u of t. So you just substitute here 1 by rc e power minus t by rc u of t into e power minus j omega t dt. So here this 1 by rc is a constant. So you take it outside. Okay. Then this u of t. What is the meaning of u of t within the integration? If any function multiplied with u of t means that integration is available only for the interval 0 to infinity. So that's why this integration you just change into 0 to infinity. Okay, then this 1 by RC you take it outside. Okay, so 1 by RC integration 0 to infinity e power minus t by RC e power minus j omega t dt. Then you just combine these two e powers. So if you are combining the e power, so we have to take a minus t as a common, j omega plus 1 by RC. Okay, then e power minus some value t divided by t. If you are integrating, we will get e power minus j omega plus 1 by RC t divided by minus of j omega plus 1 by RC. Okay, so you just substitute the limit 0 to infinity. If you are substituting the upper limit, e power minus infinity 0. Then minus of, if you are substituting the lower limit, e power 0 1. So 1 by minus this. So minus of minus plus. Okay, so we will get the answer 1 by RC into 1 by j omega plus RC. Okay, then you take this 1 by RC outside and cancel it by this one. So if you are rearranging, we will get the answer 1 by 1 plus j omega RC. Okay, this is the frequency response. So which one is the answer? 1 divided by 1 plus j omega RC. This is the correct answer. So remaining at all, the different, some mistake is there. Okay, so in this way, you just solve it. Then the next one, in next question, the frequency response is given. Find the impulse response of the system. Okay, so this question is the opposite to that of the previous question. In the previous question, impulse response is given. The question is that we have to find the frequency response. Okay, so you just take Fourier transform for the time domain signal, we will get h of j omega. Okay, but in this question, the frequency response is given as 1 by 3 plus j omega. Find the impulse response small h of t. Okay, so in order to find the impulse response from the frequency response, you just take the inverse Fourier transform. Okay, so so you see this h of j omega answer. The h of j omega answer is in the structure of 1 by some constant plus j omega. Okay, so already you know the standard Fourier transform pair e power minus at u of t. So if you are taking Fourier transform for e power minus at u of t, the answer is that 1 by a plus j omega. So you just check our given h of j omega is in this structure. In the place of a, the 3 is there. Okay, so that's why if you are taking inverse Fourier transform for this 1 by 3 plus j omega, we will get the answer is e power minus 3t u of t. Okay, so this e power minus 3t u of t is nothing but an impulse response. Okay, that is the inverse Fourier transform of the frequency response is nothing but impulse response. So this is the answer. So h of t equal to e power minus 3t u of t. So this is the answer. E power minus 3t u of t is the correct answer. Okay, this is the one type of problem. Okay, if impulse response is given means, if we are taking Fourier transform, the answer is frequency response. If frequency response is given means, if we are taking inverse Fourier transform, we will get the impulse response. Okay, so impulse response and frequency response is a Fourier transform pair. Okay, then the next question, the impulse response is obtained by dash. Taking inverse Fourier transform of its frequency response. Yes, it is correct. Then taking inverse Laplace transform of its transfer function. Transfer function means, you know, h of s, capital H of s. Okay, if you are taking inverse Laplace transform of its transfer function, we will get impulse response. It is also correct. Taking Fourier transform of its impulse. Okay, taking Fourier transform of impulse, we will get the frequency response. So this is the wrong. Then both A and B. Okay, so both A and B, it's the answer. So D is the answer. That is, the impulse response h of t is obtained by taking inverse Fourier transform of frequency response h of j omega, or the impulse response is obtained by taking inverse Laplace transform of the transfer function h of s. Okay, this h of s is otherwise called as transfer function, system function, and so on. So this is the relation between impulse response and frequency response and transfer function. Okay. Then the next thing, the frequency response of the system is the Fourier transform of its impulse response. It is true or false. It's a true only. Okay. The frequency response means h of j omega. H of j omega is nothing but Fourier transform of impulse. Yes. Okay. So it's a true only. Okay. You see the frequency response h of j omega is nothing but Fourier transform of h of t. Okay. Then the next one, the transfer function of the system is obtained by taking Laplace transform of its impulse response. Yes, it is also a true. If you are taking Laplace transform for the impulse response, we will get the transfer function h of s. Okay, h of s. The formula is that integration minus infinity to infinity h of t e power minus st dt. This is the Laplace transform of the given impulse response h of t. Okay, it is a is a true is a correct answer. Then the next question, the system produces the output y of t equal to e power minus t u of t for an input x of t equal to e power minus 2t u of t. Determine, here you just determine the frequency response of the system. Okay, so the impulse response is just deleted. That's a big question. So here determine the frequency response of the system. So what are the data given here? So for one system, the output is given. Okay, so output produced by the system y of t is given and input applied to the system is given, x of t is given. So the question is that we have to find the frequency response. What is frequency response? H of j omega we have to find out. Okay, so how can you find out h of j omega from y of t and x of t? So this y of t, x of t is in time domain, but our aim is to find out the Fourier domain answer. Okay, so that's why, so first you convert this y of t, the output and the input applied to the system into Fourier domain. Okay, so we know that the standard Fourier transform pair, the e power minus at. Okay, the signal e power minus at, the Fourier transform answer is that 1 by a plus j omega. So you just take a Fourier transform of y of t as well as x of t. So what is the Fourier transform of y of t? Y of j omega. So the answer is 1 divided by 1 plus j omega. Here the a value in e power minus at, the a value is 1. So y of j omega equal to 1 by 1 plus j omega. Okay. And if you are taking Fourier transform for the x of t, we will get capital x of j omega. So capital X of j omega equal to, what is the Fourier transform of e power minus 2t u of t? It's a 1 by 2 plus j omega. Okay. So y of j omega calculated, x of j omega calculated. Our aim is to find out the frequency response. Okay, frequency response or a transfer function. So what is frequency response? The h of j omega, it's nothing but it's a ratio of Fourier transform of the output divided by the Fourier transform of input. So y of j omega by x of j omega, it is called as the frequency response. So you just take the ratio for these two. So 1 by 1 plus j omega divided by 1 by 2 plus j omega. So the answer is 2 plus j omega by 1 plus j omega. This is the frequency response. So you just check here 2 plus j omega by 1 plus j omega. So the answer A is the answer. So you can see only small difference is there in the remaining three choices. So you have to note down the correct one. Okay, so our correct answer is 2 plus j omega by 1 plus j omega. Okay, so A is the correct answer. So if input and output is given means you just convert into Fourier domain. Then you take the ratio of y of j omega by x of j omega. It is nothing but the frequency response of the system. Okay, then the next question, the differential equation of the system is given as this one. Determine the frequency response. So in the previous some questions, in one question, impulse response is given. We calculated the frequency response. In the next one, frequency response is given. We calculated the reverse inverse impulse response. Okay, then in one thing, for one system, input and output is given, we calculated the frequency response. So here the system equation is given. Okay, the time domain differential equation of the system is given. In this equation, the y of t is the output, x of t is the input. So this equation which relates the input and output of the system. So from the equation, we have to determine the frequency response. Okay, so in order to convert, so we have to convert this time domain equation into Fourier domain first. Okay, so for that you just take a Fourier transform for the above equation. So you see the differential equation of the system, you just write, this is the given differential equation. Next, in order to convert time domain into frequency domain, you just take Fourier transform for the above equation. So what is the Fourier transform of this d squared y of t divided by dt squared? According to the differentiation property of Fourier transform, the two-time differentiation means the answer is that the j omega squared into capital Y of j omega. Similarly, plus 5 into what is the Fourier transform of dy of t divided by dt? It's a j omega multiplied with y of j omega. Similarly, plus 6 into what is the Fourier transform of y of t? Capital Y of j omega. So which is equal to what is the Fourier transform of dx of t divided by dt? It's a j omega into capital X of j omega. Okay, then in the left side, so you see the y of j omega is common. So you take it outside. So we can written as j omega squared plus 5j omega plus 6 equal to j omega into x of j omega. Okay, so and you know what is mean by the system function or the frequency response? The frequency response is nothing but it's a ratio of y of j omega by x of j omega. So this y of j omega you keep here, this x of j omega you give it to the side. So we will get the answer j omega by j omega squared plus 5j omega plus 6. This is the frequency response. Okay, so if the differential equation is given means you just take Fourier transform, then you rearrange y divided by x, that is the answer for the frequency response. Okay, so here you see which one is the answer. The first one, h of j omega equal to j omega by j omega squared plus 6j omega plus 6. So it's not a correct. The second one, 1 by this one. Okay, so it is also not correct. J omega by j omega squared plus 5j omega plus 6. This is the answer. So the answer C is the answer. Okay, so this is the one type of problem. Then the next question, for a particular input, the system produces the output y of t equal to this. Determine the input when the system function. So here what are the data given? You see for the system y of t is given. Okay, the output is given. Then frequency response of the system is given. Okay, h of j omega is given. So the question is that what is the input applied to the system? This x we have to calculate. Okay, so one data is in time domain, another one data is in frequency domain. So you just convert this time domain into frequency domain. Then if you are rearranging, we will get the answer. Okay, so first you see given that y of t is given. So for this y of t, you just take Fourier transform. Okay. So if you are taking Fourier transform for this y of t, we can written as y of j omega. Then here in y of t, there are two terms there. So you just take Fourier transform for individual term. So what is the Fourier transform of e power minus 3t u of t? Already you know the standard pair. Okay. So don't use that Fourier transform derivation equation. So you just take you know the standard e power minus 8t u of t is having the Fourier transform answer is that 1 by j omega plus a. So in the place of a, here 3 is there. So that's why the answer for this first term is 1 by j omega plus 3. Similarly, minus what is the Fourier transform of e power minus 4t u of t? 1 by j omega plus 4. Okay, then if you are taking LCM for this two term, we will get 1 by j omega plus 3 into j omega plus 4. So from y of t, we calculated y of j omega. Then in a problem itself, h of j omega is also given. Okay, this is given. And what is our question is that we have to find the input x, we have to find out. So what is the relation between y, h and x? So the h is nothing but y divided by x. So from this, x is nothing but y divided by h. Okay, so if you are rearranging, that is h is nothing but it's a ratio of y divided by x. So from this, the x is nothing but y divided by h. Okay, so you substitute the y and h here. So what is the y of j omega? This 1 by this. What is the h of j omega? 1 by j omega plus 3. So here this if this j omega, it will come to the numerator. So we will get the answer like this. So j omega plus 3, j omega plus 3 cancelled. So finally we will get x of j omega equal to 1 by j omega plus 4. Okay. So what is our question? Our question is that find the output small x of t. So from the capital X of j omega, how can you calculate small x of t? You just take inverse Fourier transform. So if you are taking inverse Fourier transform for this 1 by j omega plus 4, we will get the answer e power minus 4t u of t. Since already you know the standard Fourier transform pair. Okay, it's in the structure of e power minus 8t u of t is having the Fourier transform as 1 by j omega plus a. So e power minus 4t u of t is the answer. Okay, so you see the answers e power minus 4t u of t. So the answer A is the answer. Okay, so this is the one type of problem. And in the next question, find the transfer function of the system described by the equation. Okay, so the system time domain equation is given. We have to find the transfer function. So what is mean by transfer function? Transfer function is nothing but h of s. It's nothing but the h of s is nothing but it's a ratio of Laplace transform of output divided by Laplace transform of input of that system. Y of s by x of s, we are calling it as a h of s. Okay. So for the given system equation, so you just write the given system equation, then you just take Laplace transform. Okay. Instead of Fourier, here if you are taking Laplace transform, we will get the transfer function in S domain. Okay, since here in answer, the S domain answer is given. So you just take Laplace transform. So what is according to the differentiation property, if you are taking Laplace transform for each term, so for first term, dy of t divided by dt is having the Laplace transform answer is that s into capital Y of s. Plus, what is the Laplace transform of phi is a constant, you keep as it is. What is the Laplace transform of y of t? It's a capital Y of s, equal to the Laplace transform of x of t is capital X of s. Okay, then in the left side, you take y of s common. So y of s into s plus 5 is equal to x of s. So from this, if you are rearranging y of s by x of s, we will get h of s. So the h of s is equal to 1 by s plus 5. Okay, this is the transfer function. So 1 by s plus 5. This is the transfer function of the system. Okay, then the next question, given h of s is given, find the differential equation. Okay, so in the previous question, differential equation is given, we derived the h of s transfer function. Okay, but in this question, the h of s is given, we have to derive the differential equation. Okay, differential equation. So in reverse, we have to perform. So h of s, you just write. Okay, this is the h of s. Already know what is h of s. It's a ratio of y divided by x. Okay, then you just cross multiply these two things. So if you are cross multiplying y of s into this s squared plus 2s plus 1, which is equal to s into x of s. Okay, then you multiply this y of s to each term. So y of s squared plus 2s y of s plus y of s equal to x of s into s. So this S domain, this Laplace domain equation, we have to convert into time domain. So what is the thing we have to take? We have to take inverse Laplace transform. Okay, so in the previous problem, this equation is given. So from this equation, the h of s is obtained by taking Laplace transform. So here, from the Laplace answer, if we want to derive time domain, we have to take inverse Laplace transform. So what is the inverse Laplace transform of s squared into y of s? According to differentiation property, d squared, 2 times differentiation of the y of t. Okay, so d squared y of t by dt squared. plus 2 into what is the Laplace transform of s into y of s, dy of t divided by dt, plus what is the inverse Laplace transform of y of s, small y of t, equal to s into x of s. The inverse Laplace transform is dx of t divided by dt. So this is the answer. So d squared y of t by dt squared plus 2 into dy of t by dt plus y of t equal to dx of t divided by dt. This is the answer. So you just see here, this one is the correct answer. Okay, d squared plus 2 plus y of t equal to dx of t by dt. So A is the correct answer. So these are all the some of the questions. So already we solved so many problems in a signals and system playlist video from this third unit part. Okay, in the analysis of continuous time system using Laplace transform and Fourier transform. Okay, so if you want to learn means, so I will give link for those videos in the description box. You can see. Okay, so thanks for watching my channel. In the next video, we will see the fourth unit problems. Okay, so thanks for watching and keep watching my channel and please subscribe my channel for more videos. Thank you.